Hi there, how's it going? My name's Terry Brown. I'm the subject coordinator for 43017 Machines and Mechanisms B. And I'm just going to go through this quick introductory video just to give you a bit of an overview of what the subject's about and some of the subject details. So let me share my screen again so you can see the PowerPoint. Okay, so there we go. So let's get into the next screen. So yeah, so as I said, my name's Terry Brown. Some of you would have seen me previously in subjects such as Introduction to Mechanical Engineering, Fundamentals of Mechanical Engineering, Applied Mechanics and Design A, maybe Applied Mechanics and Design B, or Strength of Engineering Materials. But anyway, if you haven't seen me before, hi, nice to have you in the subject. And those who I have seen before, nice to have you in the subject as well. And I'm looking forward to seeing you in class. Helping me out with the subject this semester will be Dr. Ahmed Al-Zubaydi, and you would have come across him in other subjects as well, probably in materials and manufacturing, and maybe machines and mechanisms A. And what else? Maybe advanced manufacturing if you've been here for a little while. But anyway, yeah, so we're the teaching team for the subject. So the lecture schedule for this little lecture is the welcome, which I've already done. We'll have a look at the content of the subject, where this subject fits in, some of the content practical applications, and how this subject will be used in industry. And we'll have a quick look at Canvas and the subject information, assessment, textbooks, and talk about preparation for tutorials. So let's move on. So yeah, subject content. So this subject builds on what you would have studied before in Applied Mechanics and Design A. So your engineering mechanics and your solid mechanics. So the understanding of forces and moments, both external and internal, and then making use of that to determine stresses and deflections in structural components or machine components. So we're going to make use of that, and we're going to look at in more detail things or machine elements like gears, belts and pulleys, chain drives, transmission shafts, bearings, tolerances and fits, brakes and clutches, and some mechanisms. Now you may have looked at these a little bit in other subjects. So when you did Mechanical Design 1, or what's it called now? Mech Design Fundamental Design Studio 1 or something like that, where you did the Warman competition. And a lot of you would have used belts and pulleys or gears or bearings, but not really done any calculations to design and choose those properly. So what we're going to do in this subject is to do that. All right, and you can see on the screen here just an example of the kind of machine that we'll be looking at. So you've got a drive motor here, a belt drive, going into a gearbox, so a speed reducer, torque increaser, and then chain drive to some kind of driven machine. Okay, so where does this subject fit in? So this is just one view of mechanical engineering, and I'm aware that there will be mechatronics engineers in this subject as well. I haven't done this similar slide for mechatronic engineering, but you would have seen hopefully seen the classic diagram of what mechatronic engineering is, and it has that overlap of the circle with mechanical engineering in there. So anyway, so machine components is mostly what we'll be looking at in this subject. So that's in here, and then alongside that, as I said, we have your engineering mechanics, solid mechanics, a little bit of dynamics, all comes under the heading, I guess, of mechanical systems, which is part of your engineering science and analysis. A little bit of design, not too, I mean, in fact, if you do the project, which we'll get to later, there's a fair bit of design, but when we talk about design here, it's more the detailed design that we're looking at, or the embodiment design. That's not so much the conceptual design. So design process, you've done that in at least one, probably three other design subjects, which more looks at, the conceptual design process, whereas in this subject we'll be looking more at the detail, doing calculations and being able to size, choose the right size of component for whatever it is that you're designing. Okay, so we need to understand system requirements. We need to make decisions, right? Which machine elements are we going to use? Which gear are we going to use? If we're going to use gears, if we're going to use a belt and pulley drive, what size belt do we need? What shape of belt are we going to use, and so on. And then we also have a little bit of professional practice. So our technical problem solving is a large part of the subject. Communication skills, not so much, although there will be, you'll need to do that in the project if you choose to do that, and making use of digital engineering tools. So we'll have a little bit of an introduction to finite element analysis, but mostly we use things like Excel and SolidWorks. Yeah, all right. So, and just where does it fit in terms of the course? And again, I've just got the mechanical engineering course. If you're a mechatronics engineer, I think machines and mechanisms B is an option. So it's a bit more difficult to do this same kind of thing for mechatronic engineering. But anyway, this is where it sits in the mechanical engineering course towards the end here. And you've got prereqs, machines and mechanisms A, and your Mech Design Fundamental Studio 1. And they had prerequisites as well. So all of this provides the background and knowledge that you should have in order to design machines and machine elements. Okay, so some practical applications, and I'm sure many of you would know these kinds of things and seen these kinds of things and been pulling them apart and looking at them and trying to understand them for many years. So, but yeah, here's just a handheld product, fairly low level in terms of loads. And we've got shafts, gears, bearings, motors, a housing or an enclosure. So all of these things we'll be looking at and getting you to do and do some design work on in this subject. Another example, a bit bigger. So you've got this mailing machine for a printing industry, and larger loads, larger components. And here, you can't just do what you did in the Warman competition in Mech Design Fundamental Studio 1, for example, and just by trial and error, hacking things together. Oh, what can we get? What can we afford? Just chuck it in there and hope it works. You actually have to do the engineering calculations so that you know what size belts you need and so on. And just a closer view of some of the things. So spur gears, right? So we'll be doing a fair bit of work on that. Worm gears and other types of gears we'll mention, but most of our work will be in spur gears. Another machine, so I showed you this one before already. So motor drive, belt drive going to a gear reducer or speed reducer with a torque that increases the torque, then through a chain drive into a machine. Okay, so conceptually or at the embodiment level of design, we could have just gone belt, belt, belt all the way through, or we could have just done gears all the way through, or we could have just done chain drives all the way through. So part of that is the design decisions as engineers, as mechanical and mechatronic engineers, is to choose which components, which machine elements are most appropriate for this particular application. And then, so here we've got, probably SolidWorks pictorial representation of the machine. When we're doing calculations and quiz questions and your project, we'll be making use of schematic diagrams like this. So we've got our belt drive here, motor, belt drive, gears, and then through to your chain drive, and then your driven machine. So being able to draw something like this to represent the machine we'll be getting you to do in the project, and in the quizzes, the questions might look like this, and the tutorial problems that we do. Right, we'll have diagrams like this that you need to interpret and analyze and do calculations for. Again, another just a diagram showing you just the gearbox or the speed reducer, torque increaser. So we've got two sets of gears here, compounded to give us a greater reduction. So input shaft, bearings, gears, first stage of gears here, and then another drive shaft, second stage of gears, sitting here in bearings. So in having done this subject, you should be able to do the calculations to enable you to choose bearings, size the shaft, size the gears for this kind of application. And then relating it back to what you've done before, so you would have done shear force and bending moment diagrams in Applied Mechanics and Design A with me, and maybe even Intro to Mech. If you did the catapult project, then you looked very briefly at shear force and bending moment diagrams and stresses due to bending there, and we'll be making use of that in this subject to be able to correctly design and size the shaft to carry the transmission loads through this machine. Okay, again, just a diagram of bearings. Won't talk about that for too long. So in industry, typically, if you're designing something like the larger machine that I showed you, not so much the handheld drill, but if it's a larger load machine, then you'll need to follow Australian Standard 1403. I think that's still the right number. Design of rotating steel shafts, and they'll have one example in industry would be a conveyor drive. So you've got the conveyor belt here, two motors, gearbox, coupling, etc. So bearings here supporting the roller. So you need to do your calculations, and the first part of doing those calculations is to draw your free body diagrams, apply your equations of equilibrium, calculate your bearing reactions, then draw your shear force and bending moment diagrams, and then size your shaft from those shear force and bending moments. And this will be the third time I've taught this subject. The first time I taught this subject, one of my students emailed me and said, "Hey, that stuff you've been teaching me, look what they asked me to do in the internship interview that I've just been to." So they went to this internship interview, and the interviewer asked them, right, if we had a shaft here with a weight here rotating at 1,000 RPM, these loads here, how would you select the bearings to suit 50,000 hours of L10 life for this application? And they had to do that in the interview. And you can see some calculations here that the student did to try and answer that question. So yeah. All right, so let's have a look at Canvas and the subject information. So let me find that so I can put it on the screen. Yeah, make sure I get the right one. Sorry. Here we go. Right. So most of you, if not all of you, that's not the one I wanted. Let's find the right one. Yeah, most of you would be familiar. That one again. most of you are familiar with Canvas. So yeah, all right. So here's the welcome page for this subject. This video that you're watching will be in here when you go to the home site. Oh, it'll look a little bit different because I haven't put the view as student on here because it doesn't work. When I go to the next thing I want to do is to go to subject information here. So it's changed a little bit this session from what you would have seen last year. So previously this would have taken you to the old subject outline. So we don't have subject outlines like we used to do. So now we have it all integrated directly into Canvas. So you have the subject information overview, which talks about the learning objectives, the teaching and learning strategies, content, required resources, textbooks. All right, so you can see that's much shorter than it used to be. Okay, and then from there we have assessment, which do I need to go to that yet? Just let me go. Where's my PowerPoint? Right, so yeah, so I've done that. So let's go back to here. Right, so the assessment that used to be in the subject outline is now in here. Right, so as you would have seen in previous subjects, it has a mastery / pass/fail section, which are quizzes. Okay, and this subject is the same. Now, what I've done in this subject, rather than making the quiz just one big quiz, I've spread it out over four quizzes. Okay, so the 80% is still there, but you need to get an overall combined score of 80% from the 4 quizzes. So that's here. Total weight 62.5. So if you multiply that by 80%, that gives you 50. Once you've done that, you pass the subject. You don't need to do any more. However, if you want to get higher marks, then you can do the project. And I would suggest that you have a go at the project because this is, where you would actually do a more practical assessment, more authentic assessment task. Whereas the quizzes, it's split up in this little small bits. Okay, so it might say, what thickness of belt do you need? And that's it. That's all you need to know. What rating, what load rating bearing do you need for this application? Okay. Anyway, so yeah, and then for the pass level quizzes, there's practice quizzes. All right, so let's have a look at where you would actually see that. Now I'm going to click. Actually, let me just go back home first and click View as Student, so it looks how you would see it. All right, and you'll see here the quizzes show up. It might be slightly different for you, but if you can't see it there, then you go over to assignments and you'll see the pass level quizzes, and the undated assignments are the practice quizzes. Yep. And yeah, so if you count up all of these points here, you'll see that gets to 62.5. Right, so if you get 50 points out of 62.5 or 50 or more, then you've already passed. And then you can also do the project. And the project would be, let's go back from here now. Where are we? Assessment. Yep. So let's go back a step. All right. So the project would encompass something like this. All right. So there would be a motor. There would be a requirement for a belt and/or a chain drive, and there would be a gear section, a gearbox section, and there would be some shafts and bearings that you would need to select. So you would need to select some bearings and size the shafts. Right, so that's what would be included in the project, right? And you need to have a diagram, something like this, with some dimensions on here, and show the enclosure dimensions as well, right? Okay, so that's assessment. Textbooks. So the textbook is this one here, Machine Elements in Mechanical Design by Mott. Now there's an e-text version, which is $58 or thereabouts. It's which gives you 12 months access only. There are a few hard copy versions in the library that you can borrow. So if you're getting quick, you might be able to borrow one of those hard copy versions. And there's, I think, 1 or 2 in like closed reserve that you can look at in the library. And then there's some other textbooks as well. So we've got this Mechanical Design Engineering Handbook. There's links to this, directly to this, throughout the Canvas site. It's a fairly simple, or it's not simple, relatively easy to read textbook, and a more introductory mechanical design textbook than this one that we use here. Anyway, so that's freely available through the library if you want to make use of that one. But all of the tutorial problems will be based on this required, and I say required because you can pass without it, right? But you really should be reading your mechanical design textbooks. I provide a lot of what's in there through the lecture notes and tutorial notes and so on. But really, it's not my job to make it possible for you to not read the textbook. Right? My job is to help you to understand and read the textbook. All right? Anyway, there's a couple of others here when we look at mechanisms towards the end of the session. There's a couple of textbooks there that are freely available through the library, and also this really good book on finite element analysis. Okay, preparation for tutorials. If you've looked at your timetable, you see that there's a Rec 1 timetable activity, which is on Saturday morning in autumn 25. You don't have to watch it at 6 o'clock or 8 o'clock or whatever it is on Saturday morning, but you really do need to go through these pre-tutorial materials, right? So when we go back to Canvas in a section, you'll see that each week's module is broken up into 2 sections, or 2 main sections: the pre-tutorial material, which is the equivalent of the lecture, and then the tutorial. Okay, so this stuff is what would normally be done in a 2-hour lecture, which is now a pre-recorded timetabled activity. Okay, all right, and then in the tutorials, the tutors are not going to just stand there and represent stuff that was in this bit. Okay, don't have time for that. What we really want you to be doing is to actually work on problems that we'll give you. So they're provided here in Canvas in the tutorial material section, and myself and Ahmed will help you to work through that, and we'll do a little bit of presenting, but really the idea is for you to be working on problems together in class. So for that reason, the tutorials aren't recorded, but the planned tutorial problems are available before class, and the solutions are posted after the last class in the week. Okay, so at the moment there's just 2 classes, one on Monday and one on Tuesday. There may be another one, but we're not sure yet. But whenever that is sorted out, we'll after the last class in the week, that's when the solutions are posted. Okay. All right, so that's it for now. I'll see you in class. Actually, what I'll just do is just quickly go back to that canvas, so you can see that. Yeah, so we go to modules. Oh, the other thing is that if you need to revise anything from your Applied Mechanics and Design A, fundamentals of mechanical engineering and so on, there's a whole bunch of stuff here that basically I've just copied my modules from those subjects into here so that you can refer back to those. So let's go to, all right, so week 1, we've got these short little lecture thingies. So if I go into one of these, so sometimes I use less boring lectures and efficient engineer YouTube videos. Feedback I've got from previous students is that these are great, but they would still like to have my PowerPoint style videos. I don't know why, but that's what some students want. So I'm in the process of doing that. So I think these are much better than my PowerPoint videos, right? So that's why I've given them to you. In fact, this is, the way this is presented is how when we used to have live lectures and I used to write on the whiteboard, this is what I tried to do. And students would be sitting there for minutes waiting for me to draw nice pictures on the whiteboard. Whereas now, you can do them and present them as a video, but they take a long time to do. But anyway, so you'll see those, and you'll also see my my PowerPoint videos here and there. Let's go back. So we're week 1, and you can see that the tutorial solutions are there. If they're not visible when you go to see it, it'll be because it's not the end of the week yet. Yep. Or it's not the last class, last tutorial hasn't happened. Right. So if you go down here, you'll see the tutorial problems and any supporting material. All right. So this has gone on way too long. I really am going to say goodbye now and see you in class.